Hey you guys, welcome to the FRQ where we're going to discuss integrated pest management. Actually, we're going to talk about experimental design, and I have added this document to PowerSchool, which has all of the information on it, the scoring guidelines. So everything that's specific to integrated pest management, I'm going to let you look up because that's just content. I want to make sure that you are able to discuss your parts of an experiment very well and able to create a hypothesis. So we're going to cover a few of these things now. So first it says state a hypothesis right here. So if we read our question, it talks about farming and chemical compounds and organisms being killed, but honestly everything that we're doing here, we don't even need to talk about content for a little while. Let's talk first about what they're looking for in a hypothesis. If you notice here, there's nothing in here about minnows. There's nothing in here about pesticides. They want to see that your hypothesis predicted a relationship between the independent variable and the dependent variable. And so this is very important, as well as the prediction must indicate a specific direction of change. So that's your prediction. So let's talk about how we can be sure that we will include all of these things in our hypothesis. There's a format to follow which allows us to know that we've hit all of our targets. And this is if independent variable, then dependent variable. So we have to first know what the independent variable is, what the dependent variable is, and what the control is. We need to first design a laboratory experiment. So let's identify our independent variable. Our independent variable is the thing that we're changing. It's the thing that we are experimenting on. So in here, if we're designing a laboratory experiment to determine whether or not a new pesticide is toxic to minnows, a type of small fish, then we're going to want to give minnows or put minnows in an environment where this pesticide is. And we're going to want to do that at varying levels. So the thing that we're changing is the amount of pesticide. So here in our experiment, we're going to put amount of pesticide. And so our dependent variable, this is something that everybody forgets. Our dependent variable, remember D for dependent variable or data. This is the data that you're collecting. In this case, it should be a number. So it is dependent on what you change. That's why they call it the dependent variable. So because you changed the amount of pesticide that minnows are receiving, some are going to live and some are going to die, some are going to be sick. So what's the dependent variable? What's the number of minnows that are dying, or the number of minnows that are living? So this is our data. And to be sure that we are using correct verbiage, we want to make sure that we use the words increase or decrease. Increase or decrease. We don't want to say something like a bunch of minnows died. That isn't very collegiate. What we want to do is we want to say an increased number of minnows have passed, or an increased, if we increase the amount of pesticide, the number of minnows that will survive will decrease. So you're not going to say a bunch will die. We're going to use the words increase or decrease in our hypothesis. Our control, this is something that people get confused as well. Our control, it's not the constants. It's not the things that we keep the same, like the temperature of the water or the number of minnows tested on. This is the thing that, this is the group that is going to receive normal conditions. Normal conditions. So normally our fish or our minnows don't live with pesticides. And so we want to know, what do minnows look like? How long do they live? Etc., when there are no pesticides. That way we know exactly what the effects of the pesticides are. So we have the control, and we have the independent variable, and we have the dependent variable. So let's create our hypothesis. So if independent variable, then dependent variable. If we increase the amount of pesticides in the water, so here we used the word increase. So we've used our independent variable. So the independent variable is the thing that we're changing. So we have changed, or we have increased the amount of pesticides in the water. That's our independent variable. If we increase the amount of pesticides in the water, then, so this is where we need to make sure that we are predicting. And to make sure that we are predicting, we're going to use either increase or decrease. So if we increase the amount of pesticides in the water, then the number of minnows living through the season will decrease. So notice that we have made a prediction. We predicted that it's either going to increase or decrease. And we have used the dependent variable, the thing that we're measuring. There's going to be a number. So we're going to count the number of minnows at the end of the season, and it will have either increased or it will have either decreased. So that is how we write a hypothesis. So describe the method you would, so let's put a little check near that. Describe the method you would use to test your hypothesis. So here you would give a brief explanation of what you would be doing. But one thing you want to keep in mind is the number of data points that you have, and they're definitely going to be looking for this. So here you want to make sure that you are talking about the number of data points you have. They want to know that you're not going to do the test on one minnow and to see if it lives or if it dies, or on 4 minnows. They would want you to test many minnows many times so that you get real data, so that your information is reliable. If you just tested one minnow, what if that minnow was sick? What if that minnow was born with a disease? So we want to make sure that we are including plenty of data points, lots of data points. This is going to be very important. You want to make sure that your experiment has plenty of data, not just one minnow, but many minnows and many tests. Because what if you run just one test and the water has a toxin in it that's not a pesticide and you didn't know? But if you run many tests, then it's less likely that that toxin is going to be in the water over and over and over again. So we have identified our control. Our control is the thing that stays in normal conditions to compare. When you're explaining your control, what your control is, I would maybe include this is the normal condition so that we could compare. Identify the dependent variable. Remember, dependent variable is the data that you are collecting. So this should be a number, and it should be related to, it should be included in your hypothesis, and it should be related to your independent variable. So remember, we're going to connect our dependent variable with our independent variable. Now we're going to describe the experimental results that would lead you to reject your hypothesis in part A. So here, this is just stating that your hypothesis was rejected. Remember that we're not going to be using, we're not going to be using the word prove. We proved nothing with this experiment. We created a hypothesis and it was either supported or rejected. We would have to do thousands and thousands of tests on many different types of minnows with many different types of toxins to prove anything. But we did run some experiments and your data either supported, it showed that your hypothesis was correct, or it was rejected. And remember that rejecting a hypothesis is not bad. It just shows that it didn't turn out the way that you thought. And so you would here want to reject your hypothesis. So here, describe an experimental result that would reject your hypothesis. In this scenario, from one season to the next, the number of minnows did not decrease. The number of minnows did not decrease. So our hypothesis was rejected, or it was not supported. We're not going to use the word prove. So for everything else, you can just find, this is going to be specifically related to your content, which you can find in Module 33 about integrated pest management. And so you'll notice that the majority of the points that you're going to earn from this FRQ has nothing to do with content. It's all about setting up an experiment. So it's really important that you know the parts of the experiment. Let me know if you have any questions.